First of all, we will have a look on pair plot, SNS dot pair plot, and as we have just three continuous variable, so we will have a look on these continuous variable. Okay, and keep in mind as here we have categorical target variable. In the last sessions, we usually use pair plot and we will try to find the relation between the target variable and independent variables. In that cases, in the previous case usually we were having continuous target variable, so that's why we can find out the relation by using scatter plot or pair plot between the independent and dependent variable. But here we have categorical dependent variable, so we cannot use directly pair plot for that. It is of no use, or you can say it will not give you a good representation. Okay, so here I am using a pair plot and there are three continuous variables so that I can have a look either these have some correlation in between them or is any collinearity between these continuous variables. Okay, so here from the let's say we will start from one side. Uh, Here you can see from like age versus duration, there is no some significant relation. But in the case of credit amount and duration, there seems like some sort of positive correlation here. These scatter plots showing, but no such a significant. Okay, no very you can say strong relation they have. And it is also obvious like if you will consider that duration versus credit amount, then if there is a high duration, then there can be a chance that people will have or people have credited more amount if they have high duration. So high duration means a high credit amount. Okay, there can be a some relation correlation in between them. So, but there is no very uh, high correlation between the variables, and you can also see from the scatter plots. Okay, if we will plot a correlation matrix here, you can see here, yeah, duration versus credit amount has 0.62. Yeah, yes, it has some relation, but no such a significant. Okay, as here our target variable is risk and categorical, so that's why we will more focus on our relation between the independent variable and dependent variable. Okay, irrespective of the relation between the independent variables in bivariate analysis. Okay, each time we will have a risk versus some independent variable. Okay, now we have independent variables of two types: continuous variables and categorical uh, variables. Okay, and our target is categorical, so our bivariant analysis will be of two ways, like continuous versus categorical and categorical versus categorical. Okay, so we will have a look on that more specifically between the relation of independent and dependent. So first of all, categorical versus continuous, or you can say risk versus some continuous variables. And we have three: age, duration, credit amount, three continuous variables we have. And here very simple function I am using a categorical versus continuous function, and there are six plots I am using here: swamp plot, strip plot, bar plot, point plot, box plot, box plot without outliers. Okay, so swamp plot, and it's type of scatter plot, but when we have categorical data also. Swamp plot, and difference between strip and swarm is that in the case of swamp plot there is no such a overlapping, but in case of strip plots their points are overlapping. Mm, uh, in the case of bar plot and point plot, these are the actually estimate plots. You can say that it actually estimate the center tendency of values, the mean of the values with some confidence interval. where the mean is lying, or in other words, we can say that uh, these bar plot or plot are representing the if we want to represent a variable, a column, the multiple values by just a single value, uh, for that purpose of which value is representative of that column. Okay, we usually use bar plot or point plot. Okay, for very simplicity you can say it is just estimating the mean of the values. Okay, what's the difference in bar plot, point plot? I already have explained very well in the first module, but here you can see as bar plots are starting from zero position, from zero, which is always not true. There is no such a person which has zero age, but it actually to have a look of like bars, it usually start from the zero. But uh, here you can see on the side of point plot, it actually not start from the zero. And these black, and here you can say these bars are actually the uh, confidence intervals. Okay, and last one, box plot, already you have you are familiar with that. Okay, so these six plots, by using that function, here I will pass first variable as category, which is always will be a risk, and y will be a continuous variable. Okay, so by using that function I will plot six plot in one go. Okay, so first of all, risk versus age. Here you can see risk on the x-axis, and on the y-axis there is age, and there are a lot of points in case of no, not defaulter. Okay, non-defaulter customers or persons have a lot of data ages here at this region, and they the defaulters have more edges, most of the points at this uh, region, which is lower uh, than the non-defaulters. Okay, and you can get a better estimate from the power plot. Like here, the defaulters have are younger than the and than the non-defaulters. Here you can see that orange bar is less than, a little bit less than, not a very significant difference, a little bit less than the blue plot. Here you can see from point plot very clearly, as it has just on the y-axis from 33 to 37. So it actually seems like it zoom out the this difference, it has zoom out here. Like this is starting from 0 to 35, and this is 33 to 37. It actually zoom out our difference here. Here you can see on the mean of, you can say that mean of defaulters. Okay, the mean age of defaulters is 34, and mean age of non-defaulter is about 36.2. Okay, so on average you can say mostly defaulters are younger than the non-defaulters. Okay, um, but there is not such a very significant there can be a customers that are have that are elder, that are having old age, and they can be a defaulter. But on average we are saying, on average the younger customers compared to the elder customers are more prone to the default. Okay, so on average we are here discussing, not in every case. Okay, here from the box plot you can also again see here with outliers, and this is without outliers. And you can see here orange, which is representing defaulters, has lesser height as compared to blue, which is representing here non-defaulters. So on average you can say younger customers or defaulters are younger compared to non-defaulters. Okay, this can be an insight. Younger customers are more likely to default compared to elder customers. Okay, so risk versus age. Now we can see a risk versus credit amount. Again, six plots. You can see here more number of data points are in this region for the non-defaulter, and for the case of defaulter, these are in that region. Okay, but here you can see it is uh, when in the case of non-defaulter, it suddenly decrease the number of points when go upward, but here the concentration is not decreasing as much uh, speed as on the case of non-defaulter. Here you can see there is a decrease in the points, is not a much distinct as compared to non-defaulters. So if we will see from the point plot, you can see the average credit amount of non-defaulters is 3000, and while the average credit amount of defaulters is about 3900. Okay, and you can get an idea, and you can also say that the customers with let's say here you can also see in the case of let's say it's a zero, when the credit amount is zero. Okay, sorry, when the in the case of when the risk is equal to zero, in the case of non-defaulter, credit amounts are lesser as compared to the defaulter. Okay, like if you will see by the number of here the dataset, when the risk is equal to zero, dataset for the non-defaulters, their credit amount mean is 2985. Okay, about 3000. And if you will see for the case of defaulters, here you will have about 4000. Okay, so you can say that defaulters have more credit amount as compared to non-defaulters. Okay, or in other words, you can say customers with high credit amount are more likely to default compared to the customers with low credit amount. Okay, but here keep in mind, on average we are saying uh, it's not a it not means that the customer who has lower credit amount will not, definitely will not default. It's not a case. Okay, on average we are saying that customers or persons having higher credit amount more chances of default compared to the customers with low credit amounts. Now the third one is risk versus duration, and in the same way we will see that uh, instead of here you can visualize the density of the data points here, and if you will have a look on the point plot, you can see here duration of the defaulters is about 25, and average duration of non-defaulters is about 19. Okay, so again you can say that the defaulters has high duration as compared to non-defaulters. Okay, or the customers with high duration, there is more likely to default compared to the customers with low duration. Now, after analyzing the continuous versus categorical analysis, bivariate analysis, we have extracted three insights, like younger customers more likely to default compared to elder customers, high credit amount customers more chances to default compared to low credit amount customers, high duration customers more chances to default compared to low duration customers, but on average. Okay, so categorical versus categorical variables. Now we will have a look on when we have both variables categorical. Okay, and we are doing here bivariate analysis. This categorical, one categorical will be the risk, which is target, and other categorical will be other six columns that we have to describe other six independent variables. Okay, so here I will use four functions. Okay, two plots and two you can say two functions to represent the values. What are the values, what are the counts, what are the frequencies. Okay, like you can say contingency table or frequency table, you can say. Okay, first cross tab, pandas dot cross tab. It's available in pandas, so you can use that cross tab for to compare categorical columns, to see the frequency of categorical columns. Second, mosaic plot. Okay, so it's I have imported from the stats model. Third, this function I have coded by myself. Here you can see this function. And the last one we will have a count plot. Okay, total four functions we will use for each categorical versus categorical case. Okay, first of all, cross tab. Okay, sex versus risk. So in the cross tab here I have mentioned, like, on the index, there is a sex, female and male. There are just two categories here. And on the along the columns I have risk, and in the risk there are two categories, 0 and 1. So it will here plot a contingency frequency table, you can say, cross tabulation, like in the when the sex is equal to female, when the out of, or you can say, out of all females in our data set, there are 201 females are not at risk, and 109 females that are at risk. Okay, out of all males there are 499 males that are not at risk, and 191 males are at risk. Okay, you can see its documentation, pandas.crosstab. You can specify the index, what can be your index. You can plot multivariate or multi variables here. Okay, by using cross tabulation. Here the index columns, you can give the row names, column names, and you can, if you are interested, you can see the documentation of cross tab. Okay, so second is mosaic plot. It's again a type of cross tabulation. It's a graphical representation uh, to see two or more qualitative or categorical variables. It's also called crosstab or two-way table. It's used to summarize the relationship among several categorical variables. But here we are using for the just two variables for the bivariate analysis. Okay, here you can see I have used the mosaic plot. Uh, Here I am passing my data in which there are two variables, sex and risk. Okay, just two columns I have. I am passing this data, and here I am specifying my index, sex, and first index is sex and second is risk, and title is risk versus sex. Okay, now you will have a look on that mosaic plot. On the x-axis there are sex. In the sex there are two, male and female, and from the width you can understand that more number of males as compared to females. We already know about that. There are 310 females and 690, 69% we have male and 31% we have females. Okay, this width is showing here. And along the y-axis you can see here there are two categories, 0 and 1. 0 is representing here the customers who will default or not default, and one is who will default. And here you can see from you can get a visual, like, out of all females, there is there majority of females are not default, and again majority of males are not at default, and less number of minority of males are default and minority of females are default. But if you will compare that females with male category, then you can say that female are more default or are at risk compared to males. Here you can see out of all females, there are more percentage of females that are in the one category, and out of all males there are less percentage of males that are in one category compared to females. Okay, so in this way you can say on the index one, on the x-axis there are one column, one sex. Okay, one categorical column. On the y-axis there is another categorical column, and you can say index 2. Okay, if I will show you here, Okay, so here you can have a look on the mosaic plot. In the case of mosaic plot, as I told you, this is you have to pass the data, and here you have passes the uh, two columns and data set of two columns in this way. Okay, in this way you have passed the data, and here you have to specify the indexes which should be the at the position of index first index, and which should be at the position of second index. In that way, this mosaic plot actually works. Let's say you are specifying here sex as a first index, then it has made a sex column as a index, and these two categories male and female, and on the just there is a risk column, and risk has 0 and 1, two categories, and it has printed here the frequencies like the cross tabulation. Okay, like the cross tabulation you have seen. Then you have also specified the second index, which is risk. Again, risk will come towards as a second index here. So risk has two categories, 0 and 1. Now if you will plot here, like you will plot a table, a frequency table. Here you will have against the 0, there are two categories, male and female, and both have some frequencies. Okay. In the other way, in the case of one category, there will be two uh, categories, male and female, and these are the frequencies against them. Okay, now you have two indexes, index 1 and index 2, you can analyze. Okay, in this way, this is mosaic plot actually represent like on the x-axis you have or on the you have index 1. Index 1 is sex, and sex are here male and female, and out of total the width is showing that males are more in number as compared to females, and you already know that 690 males and 310 are females in the whole data set. Okay, this width is representing you the count, and on the y-axis you can say in the case of male there are 499 are non-default, and 191 one are defaulted customers, and out of our females, out of 310 females, there are 201 are that belong to 0 category, and 101 that belong to the 1 category. In this way, from the widths, from the heights, it actually represent the uh, counts, it represent the frequencies. Okay, and it's very from that visual representation, it will be very easy for you to get an idea of which category, okay, have more percentage of belonging to 0, or more percentage belonging to 1. Okay, risk is equal to 1. Okay, as it is a categorical versus categorical, so on both sides there is categorical variables. So I hope you got an idea how mosaic plot is actually plotted, and to use you can import from the stats model, and this is the documentation for the mosaic plot. And here you can pass the data in the form of dictionary, series, and dimensional array or data frame. And if you have are passing in the form of data frame, then you have to specify the index column, okay, so that it can get the order in which order you have to plot your mosaic plot. Okay, here you can see. Now from that representation, you can get an idea that females, more females are in default compared to males. Okay, more percentage of females out of all females, and you can also see from that function there are 690 males, and out of all males there are 27% belong to default category, and 72% belong to the not default category. Out of all females, 310, 35% females belong to the default, and 65 approximately 65% belong to the not non-default category. And you can get an idea that compared to males, females are more that belong to the default category. Okay, so this percentage function I you can also uh, You can also code by using the cross tab. Okay, but here I have coded by using the count. Okay, value counts. Okay, so it's up to you. You can use also by using cross tab. You can print the percentages. Okay, so fourth one is count plot, and from the count plot you can get an idea that against each, like there are two categories, male and female, and I have given here hue as a risk. So blue is representing the uh, zero category, non-default category, and one is representing default category. And you can also see the ratio of default to non-default in both male and female, and you can get an idea out of all females there is more chances here of there are more number of defaults. Okay, so there are four functions we are using here: categorical versus categorical cases. Okay, so here we have we have drawn an insight from there that female more chances to default compared to males. Okay, as there are it's not a seen that there are more percentage of females. Here you can see that females are, although they are in less percentage compare have default compared to not default, like default is 60-35 and not default 65. Although not default is in more percentage, but if you will compare the categories with other category, then you can say that female has more percentage of default compared to the male category, not compared to the not default category. Okay, so in this case you can use that insight for comparison. Let's say you have two samples, two persons, one person is male and one person is female, and you have to decide on the basis of their gender that which can be at risk. You can say that there are more chances that female will be at risk. Okay, so in that way you can use that insight. So risk versus job, you can see here from the cross tab the frequencies, and from the mosaic plot you can get a clear idea, clear representation. Here the this block has more uh, height compared to other blocks, this blue one. And here you can say highly skilled are have more number of ones compared to the other categories. Okay, more percentage of ones you can say. Here you can say you can see here from clearly highly skilled have about 34% belong to the default category and 66% belong to not default category. But in the case of other categories of job, there is less percentage. Okay, and although they are also percentage, like this is 30 and this is 38, they are also belong to the default category. We can say here that out of there are more chances to default highly skilled person compared to the other categories like unskilled and non-resident, skilled category, and there is also a category that is not in that, there is no sample belong to that category in that data set, which is unskilled and resident. Okay, but here highly skilled also less in number, 148, just 148 samples belong to that category. And although there is a less percentages of default compared to the non-defaults, can be due to that reason that we have 70% uh, customers in our dataset that have a not default category and 30% have default category. There can be chance due to imbalanced data. We have uh, here imbalance uh, categories. Okay, so but you can compare these categories, like this highly skilled have more chances compared to other categories to default. Okay, now we will quickly complete other categorical variables. In the case of risk and versus housing, you can see from here the rent and free have more number of funds, more percentage of funds compared to on. And you can also get an idea from here just the 26% default, but in the case of rent and free, there are about 40% in each cases that belong to default category. So we can say that there are more percent chances to default person who has rent housing or free housing compared to the person that who has own house. Now, in the case of saving account, this is frequencies, and when you will have a look on mosaic plot, you can get an idea that little and moderate have more number percentage of funds as compared to the rich categories. And you can also see from here that 32% about uh, little that are in a default category, and 33% that are in default category in case of moderate. But in the case of rich, there is very less percentages, and you can get an insight from there also. In the case of checking count, you can directly see from the mosaic plot, and then you can refer to the frequencies. Like here, okay, a mosaic plot will give you a good representation, and you can get directly from can see from here that red block has more height as compared to others, so little has more percentage of fun as compared to other categories. And if you want to see the frequency, you can see from the mosaic plot cross tabulation. Little has 304 zeros and 161 ones, and you can also see the percentage. Like little has 35% belong to the default category, but other has less than as compared to there. And you can say that more chances to default person with little checking count compared to the person with other checking counts. In the case of risk versus purpose, you will have a mosaic plot, and here you can see this uh, the last one, which is vacation or others category, has more number of percentage of funds. This education also have more percentage of funds compared to others. This repairs also have more percentage of fund compared to other categories, and very less radio and TV. Radio TV has very less number of percentage of funds compared to other categories. So you can see from here also that about 41% out of all vacation and other categories belong to default category, but here just 12 samples. Okay, so out of 12 samples there are 41% samples belong to the default category. Okay, and from here you can see about 39% belong to default category out of 59 samples. Okay, belong to education, and very less in the case of radio TV. You can see from here 22% belong to default category. You can draw inside like person who have taken credit for the purpose of vacations, education, repairs compared to other categories, more chances to default. And person who have taken credit for the purpose of radio TV, less chances to default compared to other categories. Okay, okay, so now we will write the insights, all the insights that we have drawn from the bivariate analysis and the insights from the univariate analysis. Okay, so in the bivariate analysis, we have seen that there are more chances to default younger customers compared to elder customers. More chances to default high credit amount customers compared to low credit amount customers. More chances to default customers who have high duration compared to the customers who have low duration. More chances to default females compared to males. High skill compared to other categories of job. Persons who have rent or free housing more likely to default compared to the persons who have their own houses. Persons who have little moderate saving count more uh, chances of default compared to other categories. In the same way, you can write all the other insights also, and keep in mind all the insights are here compared to other categories, not compared to the non-default categories. Okay, compared to other categories. Um, for a for a very simplicity, I want to again elaborate here. Like in the case of female, that out of all females, there is more percentage of females belong to the default category as compared to the male percentage belong to the default category. Okay, in this way you can say. So these are the insights that we have drawn from the bivariate, and these are the insights that we have drawn from the univariate analysis. And in the case of univariate analysis, we have this type of insights, that which category has more frequency, which variable is right skewed, how many observations we have in our data set. It's like of more towards the frequencies. Okay, univariate analysis, and bivariate analysis is more towards the relation of category of target variable with respect to the categories in our independent variables, or with respect to the variation in our variables, independent variables. Now we can use that insights for the recommendation to the bank. We can recommend to the bank that they should prefer younger customer, elder customers compared to younger customers. They should prefer the customers who have low credit amounts. They should change their policies. In that way, we can give the recommendations. But if you want to explore some insight that you have drawn from the bivariate or univariate analysis, and you want to explore more by using multivariate analysis, by using multiple variables at one go, you can do that, and we will do in the multivariate analysis also. And here in the case of bivariate analysis, you have seen a lot of insights we have drawn from it, and these are the general insights. If you want to go some depth insights, some deeper insights, then we can refer multivariate plots, and by using multivariate plots uh, we can explore more precisely the variables of the statements that we have uh, in these analysis. Okay, so for that case you can use multivariate analysis. And also the logistic regression, in the case of linear regression, I hope you remember that in the case of visualization, I have plotted a graph which is actually a linear regressor graph, and it can also be used as a multivariate analysis. In the same way, logistic regression, the model of logistic regression, the equation of logistic regression can also be used uh, to discuss multivariate analysis. Okay, but we will that discuss in the part of model building. Before that, we will explore some different plots that we can use for multivariate analysis. Okay.